All right, so I'm Brad M. I'm a FreeCAD developer. I've been working almost exclusively on the topological naming problem mitigation for the last 6 months. The work here is actually, the actual algorithm work that was done here to solve this was done by Real Thunder in his own repository instead of, and branch. Unfortunately, that code didn't get migrated into the main branch until now, which is what I've been working on. And it's required some updates and things along the way because that work was done much earlier. This particular demonstration is just going to be a pure live demo in various versions of FreeCAD. I encourage anybody who's actually here in the audience to ask questions. You can interrupt me along the way or you can ask them at the end. But the intent here is to try to do a brain dump of the things that I have learned about this while doing this process, as opposed to just giving a fixed presentation. So, you know, it's live demos. That means I'm either really confident or a damn fool or both. We'll figure it out as it goes along. So if you haven't seen it, this is a link to the description of the underlying topological naming algorithm. It's mostly accurate. There's some things that aren't quite right, but Real Thunder wrote this up, and if you're interested in digging for it, if you just do a search engine of your choice on FreeCAD topological naming problem Real Thunder, you will find this and you'll be able to get to it and look at it. So before I dig into it, I'm actually going to try to demonstrate TNP in the current released 0.21.2 version of FreeCAD. Yeah, that's the one. So that you guys all have sort of a level set as to what we're looking at here. So if I go in here and I create a new document, and I'm already in part design. So what I want to do, that's not looking great. Okay. Do it this way. All right. So if I go in, okay, make a new body, make a sketch in that body. We'll throw it on the XY plane. We will draw a rectangle. I think I have done this particular operation 1,000 times. I'm not going to bother with constraints here. Just going to close it. I'm going to pad it in order to create a rectangular prism. Pretty simple stuff here so far. And then I'm going to take this prism. I'm going to look at this face over here. I'm going to throw another sketch which I'm attaching to that face. So I've highlighted it. This sketch is going to be on that face. I'm just going to throw another object on this so it's clear what's going on. This is purely for visualization. So, not that big a circle. That'll work. And I'm going to pad this circle as well, since it's currently highlighted. That's a straightforward thing. And so now we can all see that there's this cylinder attached on the side of this particular object. Now I'm going to go back to that first rectangle. So that's that first pad. Here's the sketch in there. And I'm just going to add a chamfer to it.
You fool!
All right. Or actually, I'm going to go with the fillet on this one. So let's just take this little corner right here. And we're just going to put a curve on, right? So that all makes total sense. And then I close this. Wait, what's the cylinder doing over there? What the hell just happened? That, in a nutshell, is the results of what happens when you see a topological naming problem failure. So we're done with the old version. Now let's go look at the preliminary version of what will be the 1.0 release of FreeCAD. So again, I'm going to take a new drawing. This allows me to go right into
Question?
Yep. Go.
Did we just watch a screw up here? Is that what?
You just did,
Okay,
right? Because
okay.
you saw the cylinder that was on the left
Yeah.
just move to the right just because I changed the underlying shape.
No error message, no
Nothing,
explanation,
it just went
your model
poof.
just changed.
What I do with my students is I'll make a cube or a rectangle, something like this, and
Yeah.
I'll highlight each face and I show them down in the lower left. You can read what face name it is, what number it is.
Yep.
And then I'll put a hole through it, and then I'll show them that the face names, the numbers change, and that's the extent of my understanding of it.
And that's exactly right, and we'll get more. So first I'm going to hopefully demonstrate here this not happening, and then I'll show you why.
You need a drum roll for this one? Maybe when we get to the fillet step?
Yeah.
Question?
So another question is
Yeah.
that this is not unique to FreeCAD. This is just
That is
a
Yep.
computer
absolutely correct.
science and coding and it's a data
yeah.
structure.
It's a data structure challenge in CAD modeling, and there are different ways that you can mitigate it, but they all boil down to being able to have unique identifiers for things and being able to track them so that you can intelligently not have that cylinder flop just because the name, the user visible name flopped.
Yes,
So- Go ahead.
and all graphics engines driving CAD software are susceptible to the same issue.
That is correct.
This is not like FreeCAD made a fundamental bad choice choosing
No.
this graphics engine.
I
and
think you
it
could
only-
argue, exactly, I think you could argue that FreeCAD just until now hasn't had the development resources to go build a mitigation. So if you look at the commercial CAD software packages, they've all built mitigations for them. And not all, and they're not perfect, just to be clear.
And it's ad hoc workaround solutions. There's no one who has found the fundamental answer.
And there is no
That's-
fundamental answer?
I don't know the answer to that question.
Yeah.
That goes beyond, but my understanding is no, there is no fundamental answer to this.
The only solution is for the program to make certain assumptions, which hopefully are most often correct.
That is
But they
correct.
can be incorrect.
And what you'll hear later is talking about heuristics in order to make those guesses and how to be confident and not be confident when you're facing those situations.
Does it-
As proof of that, I can show you all later a model that you as a human can't solve, topological naming problem.
Issue.
And,
But-
and,
Go ahead.
and I want to point out that that sort of problem that you showed where things went wacky for no good reason, that used to happen in commercial CAD software when you would take a CAD file model done in one version of the software and use it in a different version of the software. That sort of fundamental changes of your shape would happen automatically and unintendedly.
Unigraphics and CATIA.
And SolidWorks.
Okay, so my next question is, does anybody have an idea of how many lines of code the solution is in, for example, SolidWorks? This is a
That's
big,
proprietary nature at that
Closed source
point.
systems.
I understand,
Yeah,
but
that's-
I understand we don't have access to, but we have to assume this is a tremendous amount of code.
And it's constantly changing,
Correct.
because they haven't solved it, they've
Right.
mitigated
Because
it,
there's
which
no
means they're,
solution. Yes.
exactly.
We're always
So,
trying to
so,
harden it
so
up.
there must be a, I know we let you get like one sentence.
This is great. This
He
is-
brought it on himself.
No,
Right.
this is exactly what we want to do in this session, because I'm sure there are lots of people that have these questions, and what we're trying to do is just clarify how it all fits together, so please keep
Right,
going.
right. So, is there an academic, like, field of research that is this
Yes.
specifically? So we have an academic and topological naming problem is the keywords used for that, or is that?
Yeah, and in fact, Real Thunder links to it, because it's not Real Thunder's algorithm, it's Real Thunder's implementation of an academically developed algorithm. I mean, this has been an area of ongoing research for decades at this point, trying to figure out the heuristics and what are the most effective ways of approaching this. So,
All right, so before I take this next step, which now this is in the current version, or maybe even slightly ahead of it, if I go back and highlight this particular face, you guys can't read it, but I can. It says this is face 1 of pad 1 that we're looking at, which can't
Live demo.
Oh, I see. Okay. So I can't actually see which face it was, but I will show you which face it was afterwards, because I'm in a body and I'm looking at the
You're in
first
the
pad and it's now looking at, so yeah, so in any case. So if I go into the sketch here, and we'll do that, same, when I find it. Oh, there it is. Same fillet, same corner. Yes, no, maybe, please. There it is. And I close this. Miraculously, it just did what you expect. It didn't move. And that's what this is basically all about, making that happen. Now, in order to make that work, what we've done is the user visible names, like those face one number names that we see, are all have a shadow name behind them, which is a much longer, what we call a mapped element name. And all of those mapped element names live in the element map, which is actually visible. You can get at it from Python, which is what I'm about to do right now, to start to show you guys what this stuff is and what it looks like. There's probably no reason to do this unless you're actively trying to develop in here or you're trying to track down a bug, but it is there and available for folks to see. So, see if I can successfully make this a little bit bigger. And will you let me?
Question,
Yes, fire.
are you operating with a mouse or on the pad?
On a pad.
Okay.
I've got a mouse if you'd like to borrow one.
That's a good idea. I have one actually in my bag, which I can go grab.
There you go.
All right, so, oh boy, that's going to be hard. Over here in the Python console, which I'm just going to clear it, we'll start off like this. So if I go in and I will highlight this so this is easier for you guys to see in a moment.
Red's never good.
Yeah, it basically means I typoed something and I don't know what I typoed. Oh,
Do you mind if I move up? I can't see very well enough. Move up here.
well, this is what you can't see very well, and it's angry because it thinks it's still running a previous command, which is a strange statement. What happened? It's all good. It's there.
We're gonna edit this part out.
That's good to know. I'm a little stumped here because I don't understand why this Python console has suddenly stopped behaving.
You want to just restart it?
That's exactly what I'm going to do.
So is there an attendance list?
Not exactly. So there was sort of an interest form that people kind of signed up with, but not exactly.
You want to, should send one around?
Yeah, sure. And actually, one thing I was thinking, I have sort of a visitors from the section up there, and I was thinking maybe everyone kind of write what state that they travel from.
All right.
Okay. So what university are your students at?
Oh, no, my students are 50, they come in 15 years old and bewildered, and they're poor and they're from broken homes. And so I'm trying to get these concepts across, and I'm sorry to belabor y'all with all of this, but because this is a thing where I'll teach them, I'll say, I'm going to show you how to do this wrong first, and I'll click on the surface and draw the next sketch. And then I'll say, now, what I recommend that you do is you make a datum plane. Now, I know you don't have to make a datum plane because you can do the sketch, but I think it's kind of tidy and it's easy to get the concept across when there's a datum plane, you know, a thing there that you can turn on and off with the space bar. So I'll show them how to, you know, do it wrong, and then I tell them they're doing it wrong, and then I'll show them how to do it right. That kind of, it's really, they're just kids, you know, 15 years old.
They're just kids.
Mm-hmm. And like I say, they're mostly poor. And don't have, you know, advantages, and don't have a lot of exposure to the things that we had exposure to when we were their age.
And then what's the
It's a 2-year course.
2-year course?
Mm-hmm. But I've had this year and last year I had a single third-year student. So I've had a third-year student this year. I had one last year, and I try to get them. It's architectural drafting is the name of the course.
Okay.
In the state of Mississippi, the standardized test is an AutoCAD certified user test, which I'm sure y'all know enough about CAD to know that's speed, right? You know, because that's in the industry, you're supposed to be fast, and that's what makes that test difficult for teenagers. And I keep saying you got to be fast, you know. But so I have to teach them AutoCAD. So I teach them LibreCAD, FreeCAD, and AutoCAD. And as I've told some people, the reason I did that is I was trained in SolidWorks, and then I didn't have the money to pay for it after I got out of school, so I never got to use it again. So that's how I'm an open source hippie in other ways, but that was my main motivation for teaching them that, because they're poor. And if they don't go to work for Ingalls Shipbuilding or Chevron or one of the local industrial things, they're not going to have access to CAD after they get out of my program unless they go to the community college. And then after that, they're not going to have access to it. So
Yeah.
I wanted them to be able to keep a hand in it. And I had the local libraries loaded FreeCAD and LibreCAD, and
Oh.
school libraries loaded it on their computers. So not that the kids utilize those
Yeah.
resources, because they don't, but I just, you know, I try to.
It's in the community and right, yeah. So you're trying to build up a knowledge base.
Mhm.
Yeah.
And the things that I wrestle with are this kind of, it's bizarre, it's a default assumption that if there's something about this, maybe it's an American mindset that it needs to be corporate or it's not, it's a toy. And I try to tell my director paid for me to come here, so that was a big thing, and I really appreciate him doing that. But you know, everybody, I try to say, look, these aren't toys, these are real CAD programs, you can do real work with this. And
Yeah, there's, I think Open Cascade's purpose was as a analysis tool, like for the power utility.
French
right?
nuclear reactors.
Yeah, right.
So
So,
its origin was,
yeah, so you'd hope that they weren't using tabletop toys for that kind of
Grad
stuff.
students got to do something, right?
And something else I would want to point out, right, if you've been in the game long enough, you realize that a lot of the closed source software, if you write a couple of hundred lines of code, there's going to be bugs.
Mm-hmm.
And
so you can fix this quickly.
well, you don't get to see what the bug was that was fixed.
Mm-hmm.
So in my field, there is a spell where academic papers were being published, where they would be like, here's my result using this version of this tool, and now here are the results that are different using the more current version of the tool.
And you can't reconcile them.
Yeah, right, it'd be some entirely different results. And so they'd be like, hey, you know, and so there is an entire body of work of people, academics doing this sort of thing, whereas an open source analysis tool, right, and I don't know if you consider FreeCAD exactly an analysis tool,
Yeah.
but you get to you get to look at what changed from one version to the other, and so when you do your benchmarking, you can see like, oh well, they changed a sign on this, or someone finally turned on the compiler errors and realized that they weren't calling the subroutine with all of the parameters required, and you're able to see what changed and how it would impact your work. And so there's a tremendous value in an open source tool.
Well, and I know you're about to get started again. I'll just say this very briefly, and then I'll shut up. From the time I was very young, I've been a creative type, whatever, good, better, worse. But so when I was walking around the neighborhood with the 5-year-old kids, and they would say, somebody say, I'm gonna be the strong man, I'm gonna be the marksman. I would say, I'm gonna be the inventor. I always wanted to be. I was always a creative, and I've spent years reading about patent law and intellectual property and all this stuff. And then I read this one book by Stephen Kinsella called Against Intellectual Property. And kind of the way I would sum it up is he says, like, I could have a set of steak knives, and I give you the steak knives, but I don't control them anymore because they're finite and tangible. But an idea I could share with everybody in the room and retain for myself, which is to say that intellectual property is an economic fallacy. And it's only enforced through violence. And so I think it really fundamental underneath all of this is that there's a notion of the economic fallacy of taking a thing that is not intrinsically scarce and trying to give it economic properties is a fundamental fallacy, and maybe mankind needs to get past this. If it's an idea, if it's not intrinsic.
So you're saying, why am I paying hundreds of dollars for Microsoft Word?
Yes, because it's not fundamentally scarce. It could be a trade secret if you maintain it in artificial scarcity. But if somebody has parallel divination and the only way you can keep him from using it is point a gun at him. So,
yeah, you have a friendly audience here, and I would love to get into that particular conversation. But we'll do that later. It's everybody's time. Apologies for the little delays here. All right, so this is an actual element map that came from this body. So I'll show you in a moment the exact derivation of it. But you'll note here we've got 9 edges, we've got 9 faces. There might be no more than 9 vertices, but just to go by faces here, when this was a rectangular prism, it obviously had 6 faces, right? Then we stuck the cylinder on it, so there's a face for the outside and there's a face for the end, right? So that's 7, 8. And then we put the fillet in there, and so that's 9. Those are the 9 faces that we're talking about that are now within this particular body. Now, when you look at this, you can see all of these things begin with like a number sign and then a hexadecimal number. And that is the hasher at work. So if you just go and look at these when they're fully baked, it's kind of confusing and it doesn't make a lot of sense to you. So I'm about to turn the hasher off and show you what the names really look like.
For those who might not know, and correct me if I'm wrong, but the Python console that he's showing here is a way to actually look at the model through an active programming language. Okay, so we actually got access to the working guts, which to your point earlier, with a closed source program, you're not likely to have access to the working guts. So if you don't know what, pardon me for the background.
Right. No, exactly. and to that point, what I'm doing here is some standard Python stuff. I took the pretty print function out of pprint, so I imported that. I want to sort this just so it's pretty, so it's not in random order, so you guys could easily see what's going on. And then now we get into where the FreeCAD Python interface shows the element maps. I'm looking at the active document, I'm looking at the body inside of that, I'm looking at the shape that's in that body, and the shape here at the Python level maps directly to the topo shape at the C++ level, and that's how all of this stuff connects. While I'm on this for a moment, essentially the topo shape is the representation of, it's the interface and the representation of all of the shapes in FreeCAD. It's the primary object that is in the part module, and it interfaces directly to the underlying Open Cascade CAD engine. So you can draw a line directly from things that you put into the CAD engine up to the topo shape as the key core thing within all FreeCAD, and then everything is built off of that. So there are operations on that topo shape. And those will be things like make a transform, or make an extrude, or those sorts of things. In the topo naming world, every single one of those methods has a corresponding method. They all happen to be in topo shape EX CPP, expansion CPP. It is in topo shape EX CPP if you're reading the Real Thunder Link Stage 3 source code, but it is a topo shape expansion if you are reading the FreeCAD main
Certain
branch.
FreeCAD maintainers don't like abbreviations.
So, in any case, that extends all of those methods with an element version of it. So you will get a make element transform that does the same thing from a geometric sense that make transform does, but it also makes sure that it is correctly updating the element map based on whatever has happened with that particular operation. And it's kind of key and important that that happen for both all of the operations that are in part, which are all the basic geometry operations, but that also happen for the things that are in part design. Part design, of course, is based on sketches primarily. That's almost the only thing that you ever use as a basis for things. And so the elements that are within a sketch are a separate element map. So there are basically two element maps going on here. There's an element map at the three-dimensional object level at the Open Cascade interface. That is all those make element functions that are inside of topo shape. And then there's another element map that is associated with any particular sketch, and it handles the two-dimensional piece of this particular problem for when you're changing that map. And so those two maps, and I will show you both of them, look a little bit different and have some different things going on. But first things first, now that you understand where this is coming from, I'm going to go ahead and turn off not app document, app active document. Yep. Use Asher. Yes. Use Asher, false. Now it's off. I'm going to recompute, which is going to regenerate all of the element maps. And now when I go back and run that same pretty print, the names just got a lot longer. So we're looking at the, let me highlight that for everybody. So we're looking, so these are essentially the same element names, except the hasher is no longer on, so they're not getting hashed. And so to read one of these for you, face 5 here of this object, I don't know which one of them is, but face 5 is based on geometry 2 in a sketch, and then it was extruded, and it is a face. That's the F on that. And as you do more operations, these names get longer and longer, and they can be hundreds or even thousands of characters long, which is why the hasher is on by default.
If you put a hole in that face, it has to become extremely more complicated.
That's exactly. So.
Does it retain the face against the face, or is that, that one vanish?
So it is doing all of this only by name matching. So what's happened here is when we attached this cylinder to that face, that attachment said pad, it was just pad in this particular case because it's the first one, pad.face think it was probably face 4, pad.face4, and that's what it knows. The shadow for face 4 originally had some particular length, and then at the moment that we are doing the operation in order to change that face, so when we went into the sketch and we added the fillet and then we closed, at the moment we hit the close, we hit a recompute that took us back into doing an execute on everything, and the execute on the pad, so the make element pad basically version of this, looked and said, oh, wait a moment, something is linking to me and I'm about to change my orientation. It does a textual match between the old shadow name of what was face 4 and the new shadow name of what that's going to be, goes back to everything that's referring to it and changes that. So the attachment value for pad 01 actually changes from being face 4 to whatever face it is now.
Oh, so the shadow names are lagging by one step of where you are in the procedure?
The shadow names are accurate as of right now, but they're not accurate for just after this operation.
All
so
right.
At the time you do the operation, we have to make sure that we update those.
So you retain the data structure from the from just before you do whatever operation
That's
you're doing.
correct.
All right. Yeah.
The history.
Yeah.
Yeah.
So, just to make things uglier, assuming we went over into the part workbench, had 2 of those and unioned them together, the shadow naming has to work across different workbenches so the model is consistent.
That is correct. And so back to those element maps again. There's effectively 2 of them. There's the one that operates on the 3D level, and at the 3D level, you oftentimes share the element map between a particular document object and its sub-objects. So at the time that you did that Boolean to take those 2 and put them together, you end up getting a unified map of everything that is then the map that you see, regardless of whether you look at the Boolean operation or you look at the subcomponents within it. And that helps with the matching challenge as you're trying to make all of that work. However, if you're in part design and you built this thing out of an extrusion, then you also have a separate element map that's just for the geometry inside of that sketch.
All I'm doing is I'm trying to understand basically the scope of this and how many areas it touches at one time and how many nooks and crannies are easy enough to miss, you know.
Yeah.
I didn't update that portion of it yet, so that's why it's mitigated sometimes.
Yeah, exactly. And so the classic failure mode that we still have, and this is in both link stage code and in main right now, is if you have a sketch and you build things based on it, and you go into that sketch and you delete geometry. So adding geometry, fine. Changing geometry, fine. Deleting geometry in certain cases will cause the numbers, the geometry list, right? We're in here referring to G2, which is literally the geometry number 2 within that sketch. If geometry number 2 isn't there anymore, you can't do the textual matching because it fails.
It breaks your history somehow.
Right, and so the bugs that we'll call them bugs because I think there are ways that we can address this, but the places where we continue to have topological naming problems in FreeCAD even after this mitigation are all related to places where you delete something. Another way to cause this to happen is, for example, to put a fin. I was just dealing with this one actually yesterday because a bug report came in. If you put a fillet on something that is in more than one object visually, so imagine you have a cylinder and maybe you have a pad on top of that cylinder, or maybe a pad coming down from that cylinder, and you look at the top of that and that is the same thing to you, but it only has one internal shadow name and it's on one of those 2 objects. And if you delete the object, you still have that top of a cylinder. It's still right there, you can still see it, but the thing that we were referring to textually is gone, and so it's going to break that link and you're going to see what looks like, it doesn't do the I'm going to move things, but it does tag that reference as being broken. It puts a question mark in front of it. And one of the opportunities that we have here, once we get past the 1.0 release, is to add smarter heuristics or alternative heuristics to this environment in order to try to solve things like that. And I'll tell you my favorite one, because I haven't disproven that it could work yet, and that is simply to look for things that are coplanar. And if there was only one before the operation, and there's only one after the operation, and they're coplanar, they're very likely the same thing. And so maybe what we should be doing, instead of flagging that as missing, is just replacing it with the thing that's still there. And so what we need to do is then explore all of the little edge cases of that, whether or not we need to have some constraints on, are they somewhat isomorphic to each other? You know, is one tiny and one of them's huge, and maybe I shouldn't do that. But that's an example of how we can add a further mitigation now that the framework is in place.
Going back to the Brody Fairhall video where he says don't use dress-ups, don't use fillets and chamfers, cut them off with a shape. I guess what you would say is that's great, but we still want the usability. We want people to be able to use dress-ups. We want this to be easy.
So the reason why there was some
because of the TMP.
Yeah.
Well, and because of something else, and the reason that there were some knowing chuckles in the room when I was going for the dress-ups on this is a known weak spot in the underlying Open Cascade engine. There are a whole lot of ways you can make it break. And so the advice to users to try to avoid going there is easier than trying to explain the exact places that this breaks.
Right.
I'll tell you one that I know of, but there could be many others as well, which is any place that you end up with 3 or more objects on the same point and a dress-up is involved, you can start to hit the issues that are in the underlying Open Cascade engine.
I think that same problem is in SolidWorks, which would then be parasolid, right? So I think that that's a problem everywhere. And in SolidWorks, parasolid is a constructive solid geometry modeler, and they fall.
So that would be like part workbench? No.
It's an underlying geometry.
That's the underlying, and maybe it'd be good to have a talk just about like what in the world those things are. But
BRL CAD. Is that,
it's a geometry library.
okay.
It's pure mathematics.
So
it doesn't necessarily have visualization.
So they fall back onto surface modeling for those things. So they actually break kind of their solid modeling and do surface modeling to try to straighten those things out. And so it's even with all the resources SolidWorks has, it's not solved.
Yeah, and that's and that point is probably really well taken here, right? This is a mitigation of a fundamental problem that has not been solved in all CAD systems. And those with more resources have thrown more tricks in there, but it's still tricks. All right, last thing, and then I think your questions have covered almost everything that I had, but this is an example of the other element map. So this time I'm printing the element map out of the sketch. And so it's showing you that and this is the sketch of the filleted rectangular prism. So it's got 5 edges and 5 vertexes in there. And these are exactly the same order that you would see if you went and looked at the geometry list in the sketcher for this particular sketch. Edge 1 is geometry 1 in the sketch. Edge 2 is geometry 2 in the sketch. Edge 3 is geometry 5 in the sketch, because remember we edited this sketch in order to put the fillet on it. So if we had looked at it when it was just a rectangular prism, this would have made complete and total sense to you. But after you put the fillet on it, the order starts to mess around and mess with you. And so the reason why we have to have that element map in there is to deal with that order change that is occurring in there. So that's the 5 edges. And then if we look at the vertices, you'll see in this form that vertex 1 is actually associated with 2 things. It's associated with geometry 1, vertex 1, and geometry 4, vertex 2. Right? That's a point at which 2 of those edges are coming together. And that's what you see for all 5 of the vertexes here, because it's a closed drawing. That in a nutshell is what I've got, but I'm really more than happy to answer any other questions or dig deeper into any of these pieces if you wish.
Curiosity question. If you have a complex enough model, is it wise to turn hashing off? What's the effect of?
I would almost argue the other direction. So from every model I've seen some pretty complex ones, the hashing actually sometimes gives you beneficial matches where things match because the hash is the same that otherwise would not have matched.
Okay.
Are you saying that the hash makes something slightly less granular, and so therefore it smooths the rough edges?
That's correct.
Okay. Makes sense.
So for the programmers out there, it's not a mathematical hash.
That's correct.
It's a summary algorithm.
Again, I'm not a programmer, so I mean, I know about some hashing from Bitcoin and stuff. But is that what we're talking about? You're taking a large body of information and as long as you don't have collisions, you're making it.
That represents the larger part.
Yeah, it should just be faster if the hash is on, right?
They're gonna say that's a
matching
efficiency.
fewer.
That's what I was saying. I didn't know
Yeah.
what the performance difference was between hashing on and hashing off. I imagine most people will leave it alone.
Yeah.
Probably in simple models, it's not a big
Yeah.
factor.
Well,
Because string manipulation is the slowest thing you can do in C++.
you're probably going to have to leave it on because unless somebody else decides to submit a patch that makes that setting permanent, because when I made this change, I intentionally did not make it permanent, so the hashing is going to go back on if you load and save and reload the document. So.
Okay, I have another stupid question. But FreeCAD does allow more granular control to a program or to a power user than a proprietary platform.
Absolutely.
Absolutely, and so there must be something attractive to big corporations that are doing extremely complicated things like going to space or whatever. You know, if you're trying to deal with things that are really involved, why is FreeCAD not more attractive than, say, CATIA or whatever? Because you can get in there in the guts of it and you can do everything you need to do.
So I think there are a lot of answers to that particular question, but I think I would argue that commercial organizations are really good at figuring out how to differentiate themselves and sell products. And I think you would discover that there are other features of those major pieces of software that make them required for that type of environment. It may be importing or exporting certain formats. It may be playing nice with other pieces of software that are in there. But those are the types of things that are much more difficult for an open source project to solve as opposed to a commercial institution that can directly tie I'm going to pay these salaries for half a year and then I'm going to have a feature that allows me to get the contract.
A bespoke solution to that particular problem and you pay for it.
Yes.
Yep. Which could be done in FreeCAD by a company.
Which we gotta remember right now, I'm gonna use the analogy of watching sausage be made. You are seeing the sausage be made here, okay? You're seeing the guts of it. I'm gonna say that easily 99% of the users of FreeCAD will never, ever bring up the discussion of, is this a hashed name or not, okay? The developer bit twiddlers that are here are gonna be talking that discussion.
Exactly.
But if somebody who's doing a NURB model of an airfoil, this isn't gonna come up.
The only way that would come up is if something goes wrong and they get in contact with the developer and the developer wants some more information and the developer says, do this magic incantation and tell me what came out of it.
Yeah, because y'all are developing the thing, but the user at NASA doesn't need to know all that stuff.
That's
Even
correct.
if he's doing very complicated.
That's correct. However, the user at NASA might want to take it, depending upon the level, might want to take advantage of a scripting environment to do higher level kinds of operations if they're doing something specific that isn't natively supported in the CAD program.
To your point earlier about why commercial companies don't use this, because this is a specialized niche of understanding. These people are not cheap to come by. Putting one on staff and keeping them on staff, you better have
You mean a FreeCAD developer?
a CAD developer.
Okay.
I've worked with mathematicians who've gone toe-to-toe with the Parasolid folks saying your algorithm is shit. You know, you gotta figure it out because it's wrong here. having that specialized talent is expensive to keep on staff, okay? So unless you're a Fortune 500 company, you're not gonna be playing in that field.
Now, looks like, did Brad leave the room? What is Onsel doing specifically? Are they a company that is going to be available for hire to corporations who need somebody with expertise? And I mean, I don't know what they
I
do.
think so.
We are, well,
Oh, you're
I'm not CTO, so take what I say with a grain of salt. But absolutely, well, if nothing else, one of the things you can't do with FreeCAD, this is way off topic, sorry about this.
Sorry.
As I said, I'm done, so it can just be general conversation.
We're spitballing.
When a corporation has a problem with a product that they spend $10,000 per seat per employee for, they expect to call a 1-800 number and have an instant response.
Yeah.
You can't get that with FreeCAD. And nor is that person on the other end of the line going to be an engineer who's waiting for your phone call. So there's no support. For the corporate world, they don't like bugs either, but some of the stuff Onsel's been pushing FreeCAD towards, we can only push, because it's not a product.
Yeah.
Was for 1.0, let's get stuff that the commercial world would consider like game over things if you don't have. And topological naming is one of
Oh,
them.
yeah, that's key.
And not having this, so until 1.0 comes out, it's not even an option for most corporations.
It's not taken seriously.
Right. Now we have enough, assembly was another thing we pushed really hard for. And that's why we donated the Onsel solver for that purpose. It was, I mean, I like to say we're just beneficial, but no, we had motives behind it.
May I ask about that? I'm just using 21.2. I've dabbled with A2 Plus and Assembly 4. I prefer A2 Plus because it reminds me of SolidWorks more. But is the